record this too. Okay, all right, let's continue on chemistry intensive. So today we're going to focus on benzene reactions. So just we skip on carbonyl reactions first. Here we go to benzene. The benzene is quite challenging. Okay, take a look on this benzene. Okay, so first thing, please ignore this diagram. Please ignore this mind map because it's very complicated and yeah, it will make you blurry as well. Okay, just focus on this. Okay, this is colorful and also much more easier to understand. Yeah, mechanisms you have. So firstly, we begin with benzene ring. So this is benzene ring. All right. So in these fractions, we can see that benzene ring is multi-purpose. It can, yeah, it's same as usual reagent you have. We can use it to synthesize many kind of reagent and also form various kind of solutions. Okay, so as you can see, the first reactions opposed by this benzene is formations of uh, alkyl halide. Okay, so this is alkyl halide. Okay, alkyl halide, alkyl here means that you're having X. Okay, you're having X. So this formations actually is you adding up your haloalkane, you form acetic. Okay, remember this is haloalkane. Okay, and then in these reactions we prefer electron carrier. Okay, this AlX3 can be AlCl3, can be AlBr3. Okay, it depends on your haloalkane, and their function as electron carrier. Okay, to carry the electron form. Okay, later teacher will show you how was these electron carrier functions in mechanisms. Okay, so in this chapters probably you have to know how to illustrate the mechanism for acylation, acylations, sulfonations, nitrations, and also yeah, that's all. Okay, we have four of this. You have to show the mechanisms. So the mechanism is a bit different compared to the other reagent you have. Okay, so from benzene you form alkyl benzene. Okay, alkyl benzene. So alkyl benzene is the substitutions of R group here lah. So for example, you have CH3Cl, and then this Cl will be substituted here. Okay, this Cl will be substituted here. So the reaction favored by benzene is electrophilics. Okay, substitution reaction. Okay, electrophilic substitution reactions. It will possess a substitutions instead of additions. Okay, instead of additions. Okay, and then from alkyl benzene, we can oxidize it directly to form carboxylic acid. Okay, to form carboxylic acid. So this is the method. It is the industrial method actually to form benzoic acid crystal. Okay, to form benzoic acid crystal. So these oxidations we can use two reagents in each. Either it can be potassium manganate or potassium dichromate. Okay, depends on the color changes lah. So this one will be purple to colorless, and this one will be orange to green. Okay, orange to green. All right, and then from benzene as well, we can pursue a acylation. So acylations here is where we adding up acyl chloride group. Okay, so this is acyl chloride. Okay, acyl chloride. At the same time, we have electron carrier lah. So electron carrier will be AlCl3 or AlBr3, dependence on your halogen you have. If this chlorine you change to Br, then you can use AlBr3. Okay, depends on your haloalkane group you have. Okay, so benzene, acylations of benzene will form benzaldehyde. Okay, probably will form you benzaldehyde. Okay, and then beside benzaldehyde as well, it also can form you a higher group, for example, ketone. Okay, dependence on your acylation, dependence on your R group. If this R group is CH3, then this H will change to CH3. Then you form a ketone. Okay, you form a ketone. So it depends, it depends on your acylations. Okay, I will show you mechanisms on this later. Okay, and then we oxidize benzaldehyde. Okay, benzaldehyde can be oxidized to benzoic acid. Okay, we can oxidize benzaldehyde to form benzoic acid. That's same as usual you have. Okay, same as usual you have. All right. Okay, and then acylations. Okay, these acylations is when we have further groups. For example, this one R group. Okay, R group here. So this R group, okay, this R group is, for example, this one. For example, this one. Okay, this one is your R. So this R later will be substituted to form ketone of this structure. So this is ketone. Okay, ketone. So aromatic ketone is the only ketone you can oxidize. Okay, the only ketone you can oxidize by using potassium manganate. Okay, it's the only ketone you can oxidize. Okay, so when you study carbonyl group, you found aldehyde, ketone, and carboxylic acid. And among these three, there's only aldehyde can oxidize in terms of aliphatic and also aromatic. But when we come to the studies of ketone, we will realize that aliphatic ketone couldn't be oxidized, cannot oxidize. Only aromatic can oxidize. Okay, only with benzene ring we can oxidize it. To form benzoic acid as well. Okay, to form benzoic acid as well. Okay, and then halogenations. So simple halogenations as usual. You are substituting halogen group into benzene to form halobenzene. Okay, and this reaction also need a electron carrier lah. So this electron carrier you can use FeCl3 or AlCl3. Okay, AlX3 or FeX3 depends on your halogen. You can use either of these. Can use Fe, can use Al, no problems. Okay, can use Fe, can use Al. Okay, and then you form halobenzene lah. Okay, besides other than that, you also will form a nitrations. These nitrations will require nitric acid, sulfur, and concentrated sulfuric acid. Okay, these two must be concentrated, and your reagent must be at 55 degrees Celsius. Okay, must at 55 degrees Celsius. OK，一定要在55度啊。OK，如果是低过55度的话呢，你是放不到你的 nitrobenzene 的。OK，nitrobenzene，这个 nitrobenzene 呢有一个很好闻的味道。OK，it's like almond smell。OK，oily 的 almond smell 啊，好像那个叫什么呢？almond 是什么？核桃不是核桃吗？哈，应该是坚果呀，坚果的味道啦，almond 啦。OK，almond。OK，and then from nitrobenzene, you can directly synthesize aniline by reduced nitrobenzene. Okay, the reductions of nitrobenzene will prefer tin in hydrochloric acid. Okay, tin in hydrochloric acid. 这个不要用啊 lithium aluminum hydride 不要 it's 2 weeks. Okay, 2 weeks. So we will use tin in hydrochloric acid to form aniline. Okay, to form aniline. Okay, so please remember this process. Very important. And another process will be this one. This one. Okay, from alkyl benzene to benzoic acid. Please remember these mechanisms. Please put a star on these conversions. Okay, and also another one, this one, reductions of nitrobenzene to aniline. Okay, please put a star on these two reactions. Okay, because later we're going to study the electron groups. Okay, in benzene we are going to study electron group. We have electron donating and electron withdrawing. Okay, the stories of these two conversions later will change either from electron donating to electron withdrawing. Okay, from electron withdrawing to electron donating. So you have to mark these two reactions together. Okay, and then when we further synthesize aniline, okay, we further synthesize aniline to form phenol by only acidic hydrolysis. Okay, by only acidic hydrolysis. You just drop a little bit of dilute acid and it can form you phenol. Okay, it can form you phenol. All right, and then if you want to directly form phenol from benzene, you can use this method by sulfonation lah. So sulfonations, we are using concentrated sulfuric acid and a little bit of acidic hydrolysis, H2O, H plus. Okay, these two comes together. Okay, comes together. You must have these two, then only you can synthesize phenol from benzene. Okay, so what are you going to do before you enter your exam hall is that you have to memorize all the synthetic scheme. Okay, as much as you can. Okay, as much as you can. You have to read all. Okay, read all. Okay, and then like from benzoic acid, okay, we can synthesize acyl chloride. So acyl chloride look like something like this. RCl, Cl. Okay, RC110Cl lah. Okay, so what you are going to do is you just change this OH group into Cl. Okay, you change this OH group into Cl by adding either SOCl2, this is 2, thionyl chloride, PCl5 or PCl3. But teacher will prefer you to use either SOCl2 or PCl5 only. PCl3, 2 weeks. Okay, 2 weeks is only able to reduce alcohol. Okay, only for alcohol lah. But that one for SOCl2 and also PCl5, yes, you can use both for alcohol and also carboxylic acid. 没问题的。Okay, if you are using it to synthesize amide, okay, to synthesize amide, you can use ammonia, concentrated ammonia and heated lah. So amide will be something like this, C double bond O NH2. Okay, C double bond O NH2. Okay, and then reductions of amide will form you amine. This is amine. Phenylmethylamine. So reductions agent we are using lithium aluminum hydrate only. Okay, lithium aluminum hydrate only. Okay, like please put a big star on studies of benzene reactions. This one you have to focus for one essay. Okay, one essay like 我们读一个 essay 的。好，那现在我们给现在老师给看一下 mechanisms， we're going to studies on mechanisms。来，我们看一下 mechanisms。OK，Okay, so this one don't feel anything, because the modules is too old already. Okay, 这两个我不用 feel. Okay, I draw another. You can take out the paper actually. You can take out paper and then I synthesize everything for you. Okay, we mix everything for you clearly here. Okay, so first, in terms of studies of mechanisms, okay, you have to know these few reaction lah. So I will go for first reactions first. Here we go for first, which is nitration. Okay, so nitrations actually is when we have benzene ring. This is benzene. Okay, this is hydrogen. Benzene have 6 hydrogens surrounded in within a cyclic. Okay, within a cyclic. And this is benzene ring. So we synthesize it by concentrated nitric acid and also concentrated sulfuric acid at 55 degrees Celsius to form nitrobenzene. Okay, this is nitrobenzene. And this is nitrobenzene. Okay, like so we have two methods to write this. So we have two methods to write this. This is the first method, which called as reaction scheme. I told you before. Okay, I told you before. So reaction scheme is that when we only stated, okay, we only shows the products and also your reactant. Okay, we only shows these two only. No byproducts and also no second reactant. Okay, but in case we are going to write in chemical equation, okay, 如果你要把它写成 chemical equations 的话呢，你的 reactions 呢 will be something like 就会变成这样子。Okay, this is chemical reactions. So as you can see, there's difference in terms of okay, there's a difference in terms of showings of products and also your reactant. So in terms of these two, which one did you prefer? Okay, actually it depends on questions. Sometimes question will ask you to show reaction scheme only. Okay, or sometimes question will ask you to show chemical equations. So it depends on you. Okay, whether you can show reaction scheme or chemical equation lah. But in case questions mentions clearly to state out the equations, then you have to write this one. The second one, you have to completely shows every single product forms. Okay, and make sure the equations are balanced. Okay, make sure the equations is balanced. But for reaction scheme, no need. You just simply shows the products and also shows the reactant and will do. Yeah, that's all. Okay. So it's very dependent. It's very dependent. Okay, like we go for mechanisms. Go for mechanisms. So mechanisms of nitrations, as usual, we have 3 steps. Okay, 3 steps. So first step we call as formations of electrophile. Okay, formations of electrophile. So like write with teachers, it will be something like this. Okay, and then okay, so this is your electrophile. Okay, so this is your electrophile. Okay, means that this is your first step, productions of electrophile. In the system now, you have already you have already prepared your electrophile, so you have electrophile inside your system. Okay, next, benzene will come and attack. Okay, benzene will come and attack. Okay, so this is second step. We have benzene ring here. So to write this benzene correctly, okay, usually the teacher will encourage you to draw in terms of bonds. Okay, you have to show the bonds of benzene lah. This one will be better. Okay, this one will be better compared to if you, in case you are drawing a circle. This one actually is not good because later you have to show every derivative of benzene. So for these mechanisms, she will highly ensures you to encourage you to eventually draw out all the bonds. Okay, draw all the bonds. Okay, so this benzene ring, okay, combined with electrophile. Okay, so benzene come and attack. Okay, benzene come and attack because benzenes contain a lot of electron. Okay, it consists a lot of delocalized electron. So it was rich in electron. Remember, mechanism is the movements of electron. Okay, movements of electron means that from a high regions of electron to low regions of electron. Okay, from a high regions to a low region. Okay, so here benzene moves to nitrate. Okay, form three derivative. So you have to draw out these three derivative. Okay, like see how teacher draw first. Okay, okay. Okay, you copy paste down first. Later I explain to you. I give you around 2 minutes to draw out this structure first. Okay, you have to draw out three resonance structure. Okay, this one we call as three resonance structures of benzenes. Okay, three resonance structures of benzene. You have to draw out all three. You cannot simply, okay, because as you see in your textbook, okay, because the textbook still using this mechanism, you remember? This one, partial positive benzene. Okay, is it correct? From your benzene, from your textbook. Okay, this structure, this little cute thing is not readily acceptable in SCPM since 2019. Okay, 2019 onward, if you draw these little tiny creatures, okay, I'm so sorry, you are going to fail your papers. Okay, you are going to fail your papers. Okay, always remember mechanisms will be a high portions in your essay. For example, these mechanisms of nitration will cost you 8 mark. Okay, 8 mark. Okay, so since one step, okay, any of these steps like you miss out. For example, you misly draw this resonance structure into these little cute things. So the whole mechanism you won't get any marks. Yeah, for this, okay，就像你画那个非常可爱的那个 structure，是很讨厌这个 structure，这个 structure 好像那个蟑螂，不是蟑螂，cockroach 那个身体一样的，好像 cockroach 那样啊。OK，所以如果你画这个 structure 对吗？你考试时候呢，mechanism 呢8分，你1分都拿不到，你会拿到一个0。因为你用错 representation 所以出来是跟你讲，那个红色的 blanky 的书 s a s b a d y 的书对吗？很早很早以前呢，就一直在跟我老师讲丢掉它，老师不要再看到那本书了。所以老师上课的时候对吗？老师是不想看到那本书的不想，因为那本书是太旧了，那已经是老师阿公的年代了，我可能老师阿公的年代学的那个 mechanism 来的。So 那个 step 呢就会，yeah, because most teachers are still using that book, so yeah, I have no idea. Okay, 那个东西是错的so you cannot write this cannot illustrate this, cannot draw this, okay, anymore. Okay, remember that okay, okay, so you have to illustrate out 3 resonance structures of benzene. Okay, now okay, is to determine the partial positive charge. So how are we going to determine that? Okay, very easy. So first, this is your substituents. Always marks your substituent. This is your substituent. Okay, the partial positive charge will come with, okay, left side of your substituent. Okay, right side of your substituent and opposite of your substituent. Okay, opposite. Okay, left, right, and opposite. 左边、旁边和对面。Okay, 左边、右边和对面。Okay, now to put the double bond. Okay, to put the double bond. Okay, to assign the double bond. Okay, you have to make sure there's no bond on the left and right side of your positive sign. Okay, there's no double bonds on the left and right side of your double bond. So it will be your first bond here. Okay, and then jump a gap here. Okay, something like this. Okay, and then next, okay, left side and right side, we don't put double bond. Okay, we begin here, 1 and 2. Okay, all right. Same things goes here, 1, 2, no double bond, and we begin here and here. So this is how we assign the double bond for the resonance structure. Okay, any questions so far? Because this resonance structures will a bit tricky. So if you got any questions, please tag teachers in the chat box. Okay. Or those who later rewatch this recording also got problems, tag teachers through WhatsApp. Okay, so this is your first step, formations of electrophile. Second step, okay, formations of resonance structure. Okay, and then third step is to neutralize the charge. Okay, third step here, you have to choose one of your resonance structure. You can choose any of this. Okay, in between these 3, choose any one. Okay, which one also can, no problems. Okay, let's see. What is substitute? Okay, a substituent like, okay, substituent. Okay, so substituent is the compound that you insert into your benzene ring. Okay, substituent. So for example, this one, in these cases, your substituent will be nitro. This is substituent. Okay, so 这个 substituent 呢，它插在 benzene 上面，所以我们就要围绕着这个 substituent 来走这个等下呢，去到那个它的 electron groups donating 和 withdrawing 那边呢，也要看这个 substituent 的。Okay, 所以第一个进到去 benzene 的那个人，他就是主角了。In this cases, substituent 就是主角，因为他是主角来的所以你一定要围绕着这个主角来转的。所以主角的左边一个 positive， 右边一个 positive， 对面一个 positive， 箭头变化的。Okay, alright. So your third step, choose any of these resonance structures to neutralize the charge. So you can choose either from this A, B, C. Which one also can, no problem, huh? Okay. So usually, teacher will do A. 通常都是呢选 A 的。Okay, like, so 我们选那个 A 的，把那个 A 的画出来。Okay, 这个是 A 啊。Okay, and then we neutralize the charge. Okay, neutralize with, okay, like 这个 case 你看啊 okay, in your first step, okay, in your first step, you already form electrophile. Okay, and you also have this one, 这个 SO3 minus, okay, OSO3 minus. Okay, this ion later will help you in the neutralizations of charge. So you have to react it. Okay, react. Okay, 我们把它 react 掉它。Okay, alright. So 要找一个 negative 来 react 它。好，箭头呢怎么 flow 呢？来，箭头从 negative flow 过去 hydrogen 这边，它 attract hydrogen。OK， 它 attract hydrogen 啊。OK， 然后 hydrogen 的 electron 呢 flow 过来 positive 这边。OK，flow 过来 positive 这边。So this forms you a new structure. Yeah, 这样子。Okay, any questions? Okay, or maybe you will ask, what is this SO3? Okay, what is this OSO3? 这个是什么呢? Okay, this one actually is your sulfuric acid. Okay, this one is actually is your sulfuric acid. In this reagent, we are going to react nitric acid with sulfuric acid as your catalyst. Okay, as your catalyst 所以你要有 catalyst 的。所以你会问老师，请问老师，我们可以写这样子 H2SO4 吗？可以是这样子的，老师不会鼓励你写 H2SO4，反而你把它画出来。等一下那个 H2SO4 好像少一个，对啊，这样子啊。对。嗯对，比较要 check。OK，对不对？这样子。Okay, SO3H. So this one will be okay. Okay, okay, come back to these questions. Why teacher will prefer you to draw this HOSO3H instead of writing H2SO4? Okay, because the original structure for sulfuric acid is something like this. This is the original structure for sulfuric acid. So by drawing this out in your mechanisms, you will understand that after this hydrogen break bonds, the electron will go back to oxygen. Okay, the electron from the bond will back to oxygen. Okay, instead of break back to hydrogen if you use this structure. So that's why in terms of mechanism, you have to correctly state out the structures of your compound because mechanism is the studies of the movements of electron within the chemical reactions. OK，所以我们呢画出来本来会更好，画出来更好啊。 OK，所以我们不要画 H2SO4，我们把它扩成 HOSO3H。OK，有什么问题吗？OK，可以再尝试 True WhatsApp，no problems。Okay, so this is mechanisms of nitration. Okay, mechanisms of nitrations. Okay, we can next mechanisms we have alkylations. Okay, alkylations. So I give you an examples of benzene. Okay, reaction schema. I draw simply with reaction scheme of CH3Cl. Okay, CH3Cl with the electron carriers of AlCl3. Okay, AlCl3. Okay, this probably will form just methyl benzene. Okay, so this is methyl benzene. Okay, so what is the mechanisms looks like? Okay, so drawing the mechanism. Mechanisms will be, okay, first step, productions of electrophile. Okay, you have to form electrophile first. So electrophile will form like something here. Okay, AlCl4 minus. Okay, and then this one will be your electrophile. Always remember, electrophile is the species with positive charge. Okay, with positive charge. All positive charge is your electrophile. And this one will be your electron carrier. Okay, electron carrier. Okay, electron carrier because it's negative charge. Okay, so this is your first step, formations of electrophile. Okay, second step, reactions of benzene to form 3 resonance structure. Okay, so in this case, your substituent will be CH3 lah. So CH3 will be substituted here. Okay, then you place the positive charge always from left hand side, right hand side, and the opposite. And the opposite, and then you put double bond. Okay, and last step is to neutralize the charge. Okay, you take any of these resonance structure with you. Okay, and then react with your electron carrier. We have one electron carrier there. Oops. The bond, okay, electron from the hydrogen bonds back to the positive charge forms a double bond. Okay, so this is the mechanisms of alkylation. Hmm. Out. Okay. Right. So we got two more mechanisms to go. Okay, like after alkylations, we have acylation. So acylations is okay. Okay, so this one will form you a ketone. Okay, ketone. Okay, something like this. Okay, so the mechanism is very easy. Same as alkylations. The method are same, just differs in terms of the uh electrophile you form. Oops, wrong errors here. That is okay. All right. Okay. So this is your electrophile. Okay, electrophile is the positive species, your mechanisms. Okay, first step. Okay, second step, reactions with benzene. Okay, form three different resonance structure. Okay, you have to draw out all three resonance structures. Okay, and then positive sign at the left hand side, right hand side, and also the opposite side. Okay. Lastly, neutralize of your benzene ring. Yeah. So, yeah. So this is the mechanisms for acylations. Oh, okay, let's see. Teacher, can you teach how to form the last one? Which one, the last one? This up. Number 3, is it? Okay. Step 3. Oh, okay. All right. So again, step 3. So step 3 is a neutralizations of your resonance structures. Okay. So we take again, like okay. So we take any of these. Okay, any of these you can take number 1, second, or third lah. But usually teacher will take the first one. Okay. So you just take the first one. Okay, take the first one and then you draw out every single things, your hydrogens, and then your positive sign here, and also double bond. All right, and then later you react with a neutralizer. So a neutralizer in this case must be negative charges. Okay, so as you can see, because your benzene is positively in charge, so you have to find something which is negative. It's same with every single mechanism. So in these cases, your negative will be only this one, AlCl4 minus lah. So you have to take it to react. Okay, you can take it to react. So AlCl4 minus react to neutralize the positively charged. So first thing that will undergoes by this AlCl4 is, okay, as you remember, this AlCl4 actually is come from this AlCl3. This AlCl3 is your catalyst. Okay, it's catalyst. Okay, the functions of catalyst is it will be consumed in first step and later will regenerate at the last step. Okay, so this AlCl4, first thing that this AlCl4 is going to do is it will attack hydrogen first. So it will attract the hydrogen. Okay, it will attack the hydrogen. Okay, and then after AlCl4 take the hydrogens, the electron from the bond. Okay, I take another color. Okay, after it take the hydrogen, the electron from the bonds will back to the positive side, forming a neutral benzene. Okay, forming a neutral benzene. Okay, so after this AlCl4 takes the hydrogens, it will dissociate to form HCl. We take one we take one chloride to form HCl and left out AlCl3 back because AlCl3 is catalyst, so it will be regenerated. Okay, it's regenerated. So catalyst at the first stage will be consumed. Okay, we consume catalyst at first stage and later regenerate at the last step. Okay, at the last step. Yeah, so this is the mechanisms for acylations, same as alkylation. It just differs in terms of the electrophile formations. Okay, we go for the next mechanisms. Okay, the last mechanisms that you have to focus is the halogenations. Okay, halogenations of benzene. Okay, so halogenations of benzene, the overall reactions will be you have a benzene here. Okay, then we react with halogen. For example, in this case, teacher use chlorine. Okay, and then same electron carrier can use AlCl3 or FeCl3, no problems. Okay, it will forms you Cl. Okay, it will form you a chlorobenzene. Okay, chlorobenzene. Okay, so are we going to illustrate the mechanisms? So first step, benzene. No, formations of electrophile first. So Cl react with AlCl3. Okay, same things. So this one will be your electrophile because it's a positive species. Okay, so formations of this electrophile, later you just repeat with the benzene resonance formations. Okay. Okay, benzene resonance formations. Okay, and then assign the positive charge on the left hand side of your chlorine, right hand side on your chlorine, and also opposite of the chlorine. Okay, and then assign the double bond. Okay, always remember the right hand and also left hand of the positive sign cannot have double bonds. Okay, same goes here. The left hand and the right hand cannot have double bond. Left hand and right hand cannot have double bond. The rest side you can put. Okay. All right, and then you take one of the resonance structure to neutralize. Okay, so to neutralize it, you need to have a negatively charged particle, negatively charged substance to attract hydrogens, and then the electron from the bonds will back to positive charge. Okay, lastly, you form something like this. Okay, HCl and AlCl3. Okay. Okay. Okay, all right. So that's all about mechanisms. Okay, that's all about mechanisms. Huh? Please understand every single mechanisms you have, especially for of these lah, for halogenations, alkylations, acylations, and also nitrations. Yeah, these four very important. Huh? Okay, these four are important. Okay, in case you have any questions, okay, also feel free to text teachers. Huh? No problem. I mean, like teacher, I still don't understand on this. Can you please talk more? Yes, no problem. Okay, you can text teachers. Okay, now like we go to this one. Okay, this one also very important in terms of product determination. Okay, product determination. Okay, so this is the effects of electron donating groups. Okay, electron donating groups. So probably you already learned this in your lectures. Anyway, to make things simpler, okay, simpler. Okay, teacher will teach you again lah. Okay, so in terms of benzene reactions, we have a lot of substituents. Okay, we have a lot of substituents. We have electron donating substituent. We have electron withdrawing substituent. Okay. Anyway, to memorize this, actually, we just have to memorize four things. Okay, we just have to write four groups, and that will be enough. Okay. So to remember, groups of electron donating. Okay, EDG. Teacher simply write it as EDG. EDG stands for electron donating. Okay, EDG. Okay, electron donating group. So electron donating group also got another name called as activating group. Okay, called as activating group lah. So this activating group, okay, you just have to remember 4A. Okay, 4A. You use this 4A, then you can understand the whole concept lah. So 4A is so what is 4A? Okay, 4A. So first A will be your amine. Okay, amine is NH2. So when benzene is bonded with NH2 compound, so the compounds are known as activating group. Okay, next will be amide. Okay, so amide is CONH. Okay, CONH. All right. Next, we have alcohol. Okay, alcohol is OH group. All right, and then the last one will be alkyl group. Okay, so alkyl group is R group lah. Okay, it's your R group. Okay, right. Okay, so we have this four. You just remember this four, then will be enough. The other out of these four will be electron withdrawing group. Okay, so you just remember this four. Okay, like EDG, electron donating groups. Okay, your 4A. Okay, EWG, electron withdrawing group out of 4A. Okay, the all compound out of your 4A. Okay, so for example, in 4A, we have, okay, amine NH2. Okay, amide CONH. Okay, alcohol OH and R group lah. So out of your 4A, it can be, okay, for example, ketone. Okay, ketone. Ketone, aldehyde. Okay, what else? Carboxylic acid, something like that. Okay, nitro, something like that. That one is out of your 4A, so it will be your withdrawing group. So donating group means, okay, like, so this is benzene. So this is your benzene ring. When benzene ring is attached with electron donating groups. Okay, so electron donating group means it will activate your benzene ring. Okay, it will activate your benzene ring, so it will keep pumps the electron in to the benzene ring. This one we call as inductive effects. Okay, inductive effects. Pump electron, okay, into benzene. Okay, into benzene. So this makes benzene, okay, increase in electron, increase the densities of electron inside the benzene ring. So when benzene ring contain a lot of electrons, the electrons are getting larger and larger. The densities of electron getting higher and higher. So this makes the resonance system become stable and stable and more stable. Okay, so when the resonance system become more stable, okay, the reactivity increases. Okay, the reactivity increases. So when reactivity increases, your rate of reactions also increases. Okay, rate of reactions also increases. The times taken for the process to success become faster and faster. Okay, faster and faster. Okay, well, when we go to EWG, which is electron withdrawing group, so we have EWG here, for example. Okay, so EWG here, when we attached it with EWG, okay, it will cause us a deductive effect. So what is deductive effect? Deductive effect is the inverse of inductive. Okay, we are taking out the electron from benzene ring. We are taking out the electron from benzene rings to the substituent. Okay, to the substituent. Okay, this one we call as deductive. Deductive means delete. Okay, delete. Okay, so these deductive effects mean pump electron out from benzene. Okay, we are withdrawing all the electron from benzene ring to the substituent. We're taking out, 我们一直把它抽出来，一直拿出来，拿出来。So by this makes the electron contained in benzene ring decrease. Okay, decrease. So makes the reactivity decreases. And lastly, rate of reactions decreases. Okay, rate of reaction decreases. Okay, like next, 我们的 EWG okay, always remember electron donating groups will prefer ortho and para positions. Ortho or para position. Okay, ortho or para. Okay, but EWG will follow meta. Okay, will follow meta positions. Okay, now I'm going to show you what is ortho, what is para, and what is meta. Okay, like so in benzene ring. Okay, so this is benzene ring, and this is your substituents. Okay, teacher write SUBS, substituents. Okay, so that's why teacher say substituents very important. So substituents 呢，它就好像主人那样的它是主人那样的。So we are going to focus on your substituent. Okay, focus on your substituents. Okay, and then this is the double bond. All right. So this the left and right hand of these substituents， 好像我们主人那样的，它的左手和右手呢叫做 auto. This is ortho positions. Okay, this is auto position. Auto. Okay, and then this one is meta position. This is meta position. And last one, the opposite of substituent will be para position. Okay, para positions. So depends on your substituents. Okay, your substituent. Okay, when your new substituent come, okay, for example, NO2 come. Okay, NO2 come, we have a new substituent want to get in this benzene ring, want to rent house 他要来租这个 benzene ring 的房子。Okay, 那么呢，他就要去进去这个 benzene 之前呢，他要先看这个主人呢是 EWG 还是 EDG 假设如果这个主人呢他是 EDG 来的，他是 donating group， 那么呢他就会租 auto position 给他，那他就来 auto 这边或者是如果他是 para 的话，他就过来 para 这边如果他是 EWG 也是要看主人的，要看这个主人如果主人他是 EWG， 那么呢他就开 meta 给他，这样子的。所以我们要看主人，主人很重要We are going to look at the substituents, the major substituent you have. Okay, so I give you an example. I'll give you an example here. Okay, I put CH3 here. Okay, teacher put CH3 here at first. Okay, so first you have to identify what is the substituent presence in your benzene ring. Okay, and then later to react with chlorine, for example. Okay, with AlCl3. Okay, so now, I want you to answer, teachers. Okay, based on these reactions, what is the substituent presence in benzene ring? Okay. Oh, someone is texting me. Okay, so what is the substituent? Seconds. Okay, so substituent is no. Okay, the substituent is CH3. Okay, CH3 is substituent like that. Okay, so substituents of this is R group. Has an R group like that. So we take a look at R group. So R group is here is EDG. Okay, 它是 EWG donating group。我们看主人的，所以主人它是 EDG 的话呢，它就会开放 auto 或者是 para 的位置。Okay, it will prefer you the next substituent to come either in para positions or in ortho positions. So ortho 是这边 ，OK para 是这边啦，所以它会开放这两个的其中一个位置给它。看我们看主人啊，说这个是主人来的，主人啊，主人讲去 auto， 那么它就去 auto 啦。所以呢，给 this 它就会放到你两个 products。OK， 一个是这样子 ，OK， 或者是这样子。auto 或者是 para 啊，所以我们不是看新的 substituent 啊，这个是客人来的，客人他要进来家里做，OK 啊，这个是客人 newcomers，我们是不看 newcomers 的，因为你是客人嘛，你进到人家家里呢，你就要去服从那个家里面的人的了，家里那边讲你做客厅你就做客厅，叫你去楼上你就去楼上了，这样子的，所以我们要看主人啊，主人的 position， 如果他是 他是那个 EDG， 他就开放 auto 或者是 para。如果主人讲他是一个 EWG 来的，那么你去 meta position， 那么就他去 meta position。OK， 他就去 meta position 啊。OK， 来 I give you another questions. Okay, for example, okay, this one. OK，直接这样子啊，直接简单一点。OK，这样子啊。So， 那么呢，你觉得他会去 auto para 还是 meta 呢？Okay，来auto para or meta. This is A, this is B, this is C. Okay, which one you think? The newcomers will go. Oops. It's not meta. Okay, it's not meta. It will go to auto or para. Okay, it's not meta. Okay, why? Again, okay, we look at this. We look at the substituents on the benzene ring. Okay, 我们看 benzene ring 上面的 substituent. So benzene ring 上面的 substituent 呢，你看它是 NH2 NH2 是 EDG 来的。Okay, electron donating group， 它是你4个 A 里面的 amine 所以它会给这个是 EDG. So when this is EDG, it will offer the newcomers to go either auto or para。auto 或者是 para我们是看那个benzene 上面的那个主人，而不是看新来的那个。我们不是看新来的那个 ，we are not going to look at the newcomers. It will be auto or para. Okay, like another example, I give you another one example. Okay, this one. If we have benzoic acid, okay, COH for example, if you have benzoic acid and it's a react with okay, let me think of one example. Okay, I gave okay, CH3 for example. Okay, all right. So okay, so which one will be the correct structure? Okay, I draw 3 structure for you. So first structure. Okay, so this is auto. Okay, this is para. This is meta. Okay. So for these questions, which one do you think will be the correct answer? Yes, finally it's meta. Yeah, it's meta. 对的。为什么是 meta? Okay, why is meta? Because we are looking at the substituent group in benzene ring. So this COOH is not in your 4A list. Okay, always remember 4A. Amine. Okay, amine, amide, alcohol, and also alkyl groups. So this one is not in your 4A. So not in your 4A means it will be EWG. Okay, electron withdrawing groups. So electron withdrawing group later it will only offer meta position. Okay, this one or this one, meta positions. So you only form one product. Okay, you only form one product. Okay, good. Finally, all right. You learned something today. So okay, always remember your 4A. Yeah, you just remember 4A and it will do. Okay, only 4A. 4A means amide, amine, alcohol, and alkyl groups. All these will prefer auto or para positions. Okay, auto or para position. All right. Good. Okay, so pandai okay, like we go for details on this. Okay, so okay, we have alkyl benzene. Okay, I just shows you once lah. I shows you one, and then the rest you can try on your own because it's just repeating only. Okay, so alkyl group. Okay, firstly you answer teacher. This R is donating or withdrawing. Okay, this one is okay, D or what's this one? Okay, like this one is D or W. It's donating or withdrawing. Okay, it's electron donating or withdrawing. Okay, now let's see. Yes, yes, good. Yeah, it's electron donating. So electron donating later when we have newcomers, when we have new things going to substitute into your benzene ring, it will prefer. Okay, it will prefer which? Okay, we prefer auto, para, or meta. Which one? Okay, when we have newcomers, for example, in halogenations, we have bromine. So this one will be attracted. This is nucleophile. I just simply draw out the electrophile for you. Yes. Okay. So alkyl benzene, your alkyl is your electron donating group, your alkyl is your electron donating group, so it will prefer auto and also para. Okay, auto and also para, so it will form you two products. Okay, two products. So you can draw up. This one is benzene. Okay, your R, this is your R. Okay, later when Cl come in, it will go to either auto or para. This is auto lah. Okay, or okay, para. Cl sorry，这样子的。Okay, same things. Look at nitrations. Okay, we no. Okay, 我们是不会看. We are not going to look at every these changes of electrophile. Always refers to the substituents, the first substituents in your benzene ring. Okay, so the first substituent in your benzene ring is R. So means that no matter what kind of electrophile come to attack, it will go either to auto or para. 怎样都好，它都会去 auto 和 para 的。我们看最原始的这个主角，我们看这个主人来的。这个主人讲，你坐在第一个位置，那你就坐在第一个位置了，永远都是永远都要 refer to 你的主人。Okay, always focus on your the first substituents. Okay. Okay. Right, you can copy, you can jot down. Okay, so while you are jogging down, okay, while you are jot down, okay, you can think of it. This is repeated, Hmm. Okay, no mind, like change this, change this to, okay, change this R to NO2. Okay, change this R to NO2. Let's see, got or not. Okay, change this to NO2. Yeah, yeah, like jot down and then you think of this. Okay, later you answer teachers, this NO2 is EDG or EWG. Okay, and then which side will the next substituent prefer? It will go to auto, para, or meta. Yeah, you have to spin your brain a bit. Think of the you just remember 4A. Okay, always remember 4A because your syllabus, your maximums of the syllabus will just cover 4A only. Just go for this 4A. Everything beside 4A or out of 4A will be electron withdrawing. Okay. Yeah. Okay. Like so, which this nitrobenzene belongs to? Which group? This is not acubenzene. It's nitrobenzene. What is this nitrobenzene belongs to? Yes, EWG. Yes, correct. Okay, pandai already. Yeah, EWG. So EWG will prefer meta position. Okay, meta positions. So it means that every kinds of electrophile, when we come to this benzene, it will attack it to meta positions. Okay, so for halogenations, you have this Cl plus as your electrophile. Nitrations, you have NO2 as an electrophile. Alkylations are as your electrophile. Acylation is R O as your electrophile. Sulfonation is OH as your electrophile. Okay, so at this moment, okay, this one is NO2. Okay, so since you have what is this? Since this NO2 is EWG, so your electrophile will attracted to meta position. So this is meta. Meta positions is okay. This one Cl. Okay. Okay. So this is NO2. R. Okay. Okay, so as you can see, no matter what kind of electrophile you have, it's not dependent. So we are only referring to the first substituent's presence in the benzene ring 啦。所以如果它是什么 group，它就会 prefer 什么位置。哎，我们只看第一个主人，看主人类的。哎，看主人的啊。OK OK，哎，可以啊，很简单的。OK，same thing goes to phenol。哎，我们的 phenol。Okay, so halogenations yang we are using Cl plus NO2 plus. Okay, later you just simply draw on your own. Okay, teacher are not going to cover every single thing with you. Okay, you can try lah. But in case you have any problems, okay, remember contact teachers. What is okay? This one is OH minus. Okay, so this azo coupling don't put it here. Okay, this one later will go for amine. Okay, so 这个不用做啊 azo coupling，这个也是 azo 的 coupling 不用做。Coupling reaction, this one is no need. Cl plus. Okay, like 我们先 determine the groups. Okay, so this OH group, okay, it belongs to EWG or EDG. Yeah, phenol. You look at this OH. Look at this OH. So OH is alcohol groups or hydroxy groups. So it will belongs to. Okay, which group does it belong to? Okay, like 我们看E. Click on the chat box. EDG. Yes. Okay, pandai. Okay, EDG. So it will prefer auto or para position. Okay, good. Like next. Okay, this phenol repeated. Okay, like this one last aniline. This aniline is NH2. NH2 is amine group. Okay, amine group. So this amine also belongs to EDG. Okay, so belongs to EDG. So you prefer auto or para position. Okay, so later you draw the products. Okay, later you try to draw first. In case you have questions, then you text teachers. Okay, then you text teachers. Okay, like so this one, both toluene and aniline undergo nitrations with the presence of oh my god, with the concentrations of nitric acid. Okay, with concentrated nitric acid and concentrated sulfuric acid. So name the types of the reactions. Okay, blah 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 and blah blah. Okay, so this one, like we are going to study this. So what is structure give you just now? Is nitrations of aniline and toluene. Okay, like okay, like we go to nitration first of toluene and aniline. So toluene, okay, toluene is methylbenzene. This is the common name for methylbenzene. You have to know these two. Okay, whereas aniline. Aniline is aminobenzene. Okay. Okay, so this is an aminobenzene. So both of these are EDG. This is EDG, correct? Group. So this one also EDG. Yeah. So this is EDG. So both are EDG. Now we are reacting these two products in concentrated HNO3 and concentrated H2SO4. Okay, so these reactions actually is nitration. Okay, it's nitration reaction 来的，是一个 nitration 的一个 reaction 来的。Okay, 所以呢，我们可以 observe 到什么东西呢？来，OK，我们先 react toluene 先啊，我们先 react toluene 先。所以呢，toluene，OK，react 跟 HNO3，OK，concentrated and also concentrated sulfuric acid。Okay, 55 degrees Celsius. So 这两个 reactions 呢，它会 form 新的 electrophile。So 这个 electrophile 呢是 NO2 plus 来的，它会去哪里呢？OK，看这个是 EDG 啊，EDG，所以它会 prefer either auto or para。OK，auto 或者是 para。所以我们考试的时候呢，你写随便一个就可以了的，你写 either 是 auto 或者是 para 就 OK 了。OK，你写 auto 或者是 para 就 OK 了的，不需要两个都写啊。Okay, so we're going to auto or para. So auto is here lah. Okay, 加上没有加了。Okay, we're going to auto position. Okay, now shows the mechanism. So how mechanism is same lah, same as previous. So we have HO and O2 react with HOSO3H. Okay, all right. Okay, and then okay, so you have your new electrophile ready. This is your electrophile, right? So first step you're done. Now second step, your benzene come and attack. Okay, now don't remember your benzene has substituents already. This is CH3，它已经有了 CH3。So 在它的 mechanism 的时候呢，这个 CH3 的位置是不会改变的。Okay, it won't change. Okay, alright. Like now, it's a bit different. Your CH3 will not change. Okay, your CH3 will not change. And now your NO2 will go to the site, the new site. So in yours, in your case right now, this is EDG. So it will prefer auto or para. So you choose either the NO2 will go to auto or para lah. So in this case, teachers already chose to go auto. So next, your NO2 will directly attach it on auto. Okay, will directly attach in auto. Something like this. 它 attach 在 auto 了的。OK，attach 在 auto 了啊。OK，然后呢？然后我们就照平常去做那样就好了的。OK，now to plot the positive sign same as usual。OK，我们一样的。OK，那我现在刚刚进来的 substituent 呢是这个。OK，刚刚进来的是它，所以我们要放 positive sign 的时候呢，就要看刚刚进来的那个。OK，look at the new enters electron groups. So now the left hand side, right hand side, and also opposite side. Okay, and also opposite side. Okay. Now put a double bond. Okay. Okay, put double bond. Okay, and then lastly, you choose one to get neutralized. Okay, usually teacher will choose the first one. Okay, and then you take a negative signs complex to neutralize your charge. Any questions? It's just same as what you have did just now, but a little bit different is here. Okay, you have electron group here. 它的差别就是刚刚呢，我们是没有这个的，没有这个的可是现在有多这个，可是它也不会影响到 anything 啦。Okay, it won't disturb you anything. Okay, and always remember the positive sign assigned is dependent on the new entered electron groups. 刚刚进来的它就会取决于，你就会去 effect 到你的 positive charge 要放在哪里。因为你看它这个是刚进来的刚刚它 attack 进来的，粘在这边的所以呢 positive sign 就要迁就它左边，你看迁就它的左边，迁就它的右边和迁就它的对面。一样的它的 concept 是一样的。Okay, step 3 can just write instead of HOSO3 step 3 can, step 1 cannot. Okay, step 3 can means that this one the final products you can change to H2SO4 can, no problems. Okay, but your first step here, this one cannot. Okay, this one cannot. First step cannot, but third step can. Only for the last products lah. Okay, final product can. Okay, no problems. Yeah. Okay, and then later you just repeat with the same things for amine. Okay, for amine. No. Give me a second, sir. Amine cannot directly synthesis. 可以的，可以的，同样的，因为我们是 aniline aniline 所以等下呢，你可以做，就讲说你可以 you can use this okay, you can use these same things, okay, and then you synthesize nitrations 啦，okay, just doing a simply way, okay, 你可以这样子的，上面呢你放一个 NH2，因为我们是做 notes okay, 你可以这样子，因为他们是同样的 group, okay, amine and alkyl are in same group， 因为他们是 same group 来的，所以他们都会 prefer auto para positions。Okay, auto para position. Okay, because teacher don't want to repeat 2 times. So you can repeat 2 times, no worry. You can try on your own after this. Okay, after class, then you take a new paper. Okay, you try to refresh back what you have learned about the mechanisms. Okay, about electron donating, withdrawing, auto para and meta positions. Okay, auto, meta, and para positions very important. Yeah, very important stuff. In terms of determining the products lah. Okay, and then for tomorrow, we go for this functional group and test. Okay, tomorrow just a very simple and things only. Okay, but this one teacher will go through very fast because you have to read it on your own. Okay, I'm not going to discuss every single thing with you. Anyway, in terms of synthesis, yes, this one I will focus a little bit lah tomorrow. Okay, we'll go to synthesis products one by one, and also distinguishing. Okay, and also this equation. Okay, after that, tomorrow is Monday. So after Monday, we'll go for carbonyl, and then go for question based. Okay, we have the second module. Yeah, second module. Your exam is your exam is on 10th of April. Okay, 10th of April. So class will conducted until 9th of April lah. Okay, until 9th of April. Okay, so in case you have, exam on that day and then you are not available, okay, it's okay. You can just rewatch the recordings when you are free. And no worry. All right, so I guess that's all for today. Please remember to try the reactions of aniline with nitrobenzene. Okay, you take F4 papers and then you dry first. Okay, if you stuck or maybe you cannot do that, then no need to text teachers. Okay, all right. So make sure trying make everything perfect. So I stop the recording here.